Welcome to this program, which will cover the subjects of priming, mixing, spraying and curing, showing current technology and methods. But before we can even think about cosmetic primers, it's important to consider the type of surface to be painted. So, let's start with the basics. Although many panels in modern cars are made from untreated steel, most steel panels are now zinc-coated or zinc-galvanized in some way during manufacture, and a few manufacturers make extensive use of aluminium instead of steel. Depending on the paint system used, these surfaces may require different corrosion protection primers. The acid in some etch primers may attack zinc coatings, so the paint manufacturer's literature should always be consulted to discover suitable materials. Here at Thatcham, we use an oxide primer for bare and zinc-coated steels and a phosphoric acid etch primer for aluminium. Peugeot and Citroën produce a special resurfacing kit for zinc-coated panels, which must be used to ensure the warranty is maintained. Electrophoretic primer should be lightly prepared to provide a key. Remember, this E-coat, as it's often known, is applied by the vehicle manufacturer to protect the panel, and it's not available as a repair material, so don't remove it unnecessarily. Where the E-coat has had to be removed, a corrosion protection primer suitable for the base metal should be used in repair. An aerosol is very useful for small areas, but it must still be used in a proper booth. Older vehicles, originally finished or previously repaired with cellulose, can cause problems. An isolation primer should be used, especially if the vehicle has been painted before and the cellulose coating is thick. This will prevent the old cellulose from flowing during baking, which could cause newly applied 2-pack to crack. Thermoplastic acrylics are no longer in common use, but may be found on older Vauxhalls and Rovers, and more recently on Jaguars and Rolls-Royces. They're used for straight colour and metallic finishes. TPAs aren't just temperature sensitive, but also solvent sensitive. Spraying technique is important. Care must be taken to avoid applying too much paint in one operation, thus allowing solvent evaporation to occur rather than having a build-up of solvent in contact with the TPA base material. A maximum oven temperature of 50 degrees Celsius must be observed to prevent paint flow. TPA will continue to be available as a repair material until at least 1993. If it cannot be obtained, then an isolation primer followed by a standard 2-pack material should be used. Thermosetting acrylics, TSAs, are frequently used by vehicle manufacturers, especially for metallic finishes. They can be overcoated without difficulty. Primers are used between the substrate and the color coats to provide adhesion, improve corrosion resistance, and shape the panel. A 2-pack primer is now essential to comply with the terms of manufacturer's warranties. A guide coat, usually in the form of a satin black aerosol, is applied over the primed area. This ensures that every part of the surface is rubbed down, which is essential for achieving a totally smooth surface. Consistently good results are obtained using this method, but baking and flatting destroy the masking, so the car must be masked up again for spraying the top coats, a time-consuming operation. The extra work involved can be avoided by the use of primers wet on wet. These are best used on bolt-on panels in perfect condition or on interior panels. The 2 wet-on-wet primer coats can be applied directly onto the substrate, followed after 10 minutes flash-off by the top coats. However, any imperfections in the surfaces to be primed, or any dirt inclusions in the primer, will show through the final finish. The problem of very visible sanding marks can be overcome using a combination of brush-on primer and wet-on-wet. A standard 2-pack primer is brushed on over the oxide primer without thinning, so it will give a high build. Curing overnight saves on both booth time and energy costs. Next morning, the primer is flatted. This may take slightly longer than usual due to the thickness of the primer. If an excessive amount of primer is necessary to achieve coverage, then obviously a filler must be used. Any bare metal revealed during flatting must be recoated with the oxide primer. The operation is completed with the application of 2 coats of wet-on-wet primer and 2 colour coats. When it's known from experience that the covering power of the top coats is weak, primer may be tinted. Although initially more expensive, it can save time later. Fewer colour coats will be required and less paint. In general, only white primers should be tinted, and the paint manufacturer's instructions must be followed with regard to ratios. Usually, only pastel shades can be produced, but special tintable primers can achieve more saturated colours. The test panel shows the much stronger top coat colour obtainable with the help of a tinted primer. Remember that many of the materials used in vehicle refinishing are dangerous. Thus, they are covered by the COSH regulations. Spraying must be carried out in a proper booth, and operators must wear appropriate protection at all times. Sealing is a subject in itself and is covered by a separate program. Modern urethane sealers don't suffer from problems such as drag or sag. Sealing usually takes place after the primer has been flatted and is followed by the application of stone chip coats. When using wet-on-wet primer, any sealer and stone chip required must be applied before starting the wet-on-wet process. Before mixing any colour, an accurate match must be achieved. Remember when using the colour swatch to check side and face tones, and always ask for a second opinion. The microfiche contains details of the amounts of the various tinters required for a specific colour. The ingredients are given in cumulative form, so as the ingredients are added, the weight given on the scale should correspond exactly. Only minute amounts of tinter are sometimes required, and quantities are given on the fiche accurate to 0.1 gram. This means that if only a small amount of paint is required, a greater quantity often has to be mixed than is needed. Most paint manufacturers give mixing information for half, 1, 2 and 3 litres. Research has shown that by moving the decimal point on the 2-litre formula, a minimum quantity of 0.2 litre can be mixed. However, trying the same procedure with the 1-litre formula can lead to colour variations due to inaccuracies produced by trying to use very small amounts of some tinters. Great care is needed to ensure accuracy, and ingredients should be added very slowly. If a mistake is made, paint may be wasted, although an incorrect mix can sometimes be used as an undercoat or on the inside of panels. To overcome this problem, some paint manufacturers are now offering a computerized system linked to a set of scales which have an intelligent head interacting directly with the computer. The computer also contains all the information formerly stored on microfiche. If too much of one of the ingredients is added to the mix, the computer can work out the changes necessary to the other ingredients to result in the required colour. Whatever the colour, once it's been mixed and the hardener added, it must be thinned to the correct viscosity as given by the paint manufacturer. Thinners are solvents which evaporate from the paint during spraying and curing. They thin the paint sufficiently to allow it to be applied with a spray gun. There are 3 types of viscosity cup in common use: the Ford 4, the BSB 4, which is the British one, and the DIN 4, which is perhaps the most common, certainly in Europe and now in the United Kingdom. Paint must be at room temperature between 20 and 25 degrees Celsius before checking viscosity. Any errors can lead, for example, to the paint being too thin. Consequently, additional coats would have to be applied, resulting in a flat finish and other problems which would require costly rectification. Inaccurate viscosity readings can also cause a colour change when working with metallics. Cellulose finishes require a 50-50 mix with thinners, so during application more than half the mix will evaporate into the air and must be dealt with safely. High solids, HS, and medium solids, MS paints are now available. They have a higher colour density and so fewer coats are required, leading to less work and less solvent evaporation, although these systems do also have their problem colours which don't cover well. Thatcham has now adopted the use of medium solids paints for all refinishing work. There are two types of spray gun in common use: the suction feed gun, which is often considered to be the better balanced, and the gravity feed gun. This is more efficient and is better for heavy materials and for controlling the application of metallic. However, the choice is largely a matter of personal preference. Standard paint guns use high pressure to produce finely atomized paint molecules, which result in a high-quality finish. However, some research has shown that up to 65% of the paint may be wasted in overspray, as can be seen if the booth extractor is switched off. Environmental legislation in the United States of America has hastened the development of high-volume, low-pressure, or HVLP guns. These deposit more paint on the vehicle, resulting in material savings of up to 50% and a corresponding advantage to the environment. In the United Kingdom, HVLP guns are usually considered to offer insufficient quality for top coats, so their use is restricted to priming, stone chip, and commercial vehicles, where the standard of finish is sometimes considered not to be so important, and material savings are more obvious. Before starting to spray, any gun must be properly set up. Air pressure should be adjusted according to the paint manufacturer's instructions. A pressure gauge should be used at the gun so that any pressure loss from long air lines or breathing apparatus is taken into account. Fan width should be set to suit the size of the job. The air and paint mix should also be checked and adjusted if necessary. The gun should be held at right angles to the workpiece at a distance of 15 to 20 centimeters. This distance must be constantly maintained, so the painter should use a long arm movement rather than a short wrist action. The gun must also be moved at a constant speed. Triggering is a useful technique when painting a large area, where one set of gun passes will overlap another at the ends. Remember that the gun must be moving when triggering on and off. Also, when triggering on, slightly heavier paint application will occur, so in this case the distance should be adjusted accordingly. In general, when blending in, the standard gun technique should be varied to an exaggerated arcing motion, always directing the gun from the center to the edge of the sprayed area. Controversy sometimes surrounds the subject of painting inside panels. For example, Volkswagen Audi require the use of color coats directly onto the electrophoretic primer, while most Japanese manufacturers use a colored ground coat on the insides of panels. A special formula is required for this ground coat, and problems can sometimes be experienced in obtaining a good match. Fortunately, most vehicle manufacturers issue instructions on this subject, which must of course be adhered to. Most modern body shops incorporate a combination spray booth and oven, which has generally been regarded as being the most cost and space-effective solution to curing. Many repairers are now taking advantage of the time savings which can be achieved using infrared. There are a variety of small infrared units on the market for handheld or stand use. These can save tying up the main oven to cure a small or medium-sized area, as well as saving on the oven running costs. Infrared arches are also available, which can be installed inside a paint booth. They offer reduced curing times, 5 to 10 minutes with 2-pack materials, and reduced energy consumption over a traditional oven, at least half when curing a whole car, and correspondingly more for individual panels. As with all infrared heaters, it's only necessary to cure the area which has been repainted. However, the insides of panels and bodies aren't so easily dealt with by infrared, which only affects what it's pointed at directly, although this also means that energy isn't wasted heating the surrounding air. It's worth noting that an infrared arch installation can incur substantial investment, especially as a 3-phase power supply will be required. Another method of generating savings during curing is the use of accelerating additives in the paint. Most of the paint manufacturers produce a fast-acting hardener. However, these should only be applied to small repaired areas because their use can result in a slight reduction in the gloss finish. They should always be air-dried at low temperatures. This program has explored various processes of interest to the vehicle refinisher. However, it should be remembered that Thatcham paint times for exterior panels have been based on the use of a fully dry flatted system using 3 coats of primer, 3 top coats, and when using base coat and clear, 3 lacquer coats with 5 minutes flash-off between each coat. Now that Thatcham has adopted the use of medium solids paint, each Thatcham single panel time or combination will be reduced by approximately 0.4 of an hour to take into account the reduction in the number of coats required. It's also worth noting that a Thatcham time for straight colour is increased when using base coat and clear to allow for lacquer coats, and a further increase is made for metallic base coat and clear finishes to cover blending in on adjacent panels. If you would like further information about the topics covered in this program, Thatcham offers a wide range of paint courses at our purpose-built, award-winning training centre. We have also produced a number of publications and other video programs about painting and other body repair subjects.
Now,